Anne is having a new front gate made and has decided on the design below. The gate is 2 meters wide and 1.5 meters high. The horizontal bars are 0.5 meters apart. Calculate the common length of the bars AF and DE in meters. So here's AF. And DE is supposed to have the same length as AF. Well, let's look at this red triangle here. It's a right angle triangle. This distance here is 0.5 plus 0.5, which is 1 meter. And the distance from here to here is 2 meters. Okay, we can apply Pythagoras to get the hypotenuse of this right angle triangle. We see that D is root 5. To 3 decimal places, this is 2.236. In order to secure the bar AF to DE, the manufacturer needs to know the measure of the angle EGF and the common distance AG equals DG. So we need the distances here shown in green. Now, let's start by getting this angle here. Actually, it'll be maybe a bit easier to see what's going on by getting this angle here, because this angle is part of this right angle triangle that we saw earlier. I will call this angle A. So we have tan A equals opposite over adjacent. The side opposite A is 2, the side adjacent to A is 1. To 3 decimal places, angle A is 63.435. Now, let's look at this isosceles triangle. That's this green triangle here. Triangle AGD. These are the two equal sides. Well, that's what we're given, that AG equals DG. We haven't found them yet, but we know they're equal. So the angles that are opposite them are equal. So this angle is equal to this angle down here. So both of these angles are equal to A. So what's this angle here? It's 180 degrees minus A plus A. 180 minus 2A. But of course that's the same as this angle here, because these are opposite angles. So now we can find this angle. That's what we want, angle EGF. To 2 decimal places, that is 53.13 degrees. And we want this angle to the nearest degree. So to the nearest degree, that's 53 degrees. Next we want to find this distance here. That's DG, which is the same as AG. We can use the sine rule here. We can say that this side, which I'm calling little a, divided by the sine of the angle that's opposite it, capital A, equals this side little b divided by the sine of this angle here. So we need little a. So little a is b sine A divided by sine B. Just multiply both sides by sine big A. So we get the sine of 63.435, so that's sine of A, and we have to multiply it by little b, which is 1.5, and we have to divide this by the sine of big B, that's the sine of 53.13. So to 3 decimal places, this is 1.677. We can also do this problem by considering these two similar triangles, these two blue triangles. From part 1 we saw that the distance from D to E was root 5. The distance of C to E is 0.5 plus 0.5, which is 1. The distance from here to here is half the height of the gate. That's half of 1.5, which is 0.75. So we're just using the symmetry here. These two blue triangles are similar because this angle is the same in both triangles, of course, and they're both right angle triangles. So if two angles are the same, then the third angle is automatically the same. So since the triangles are similar, corresponding sides are in the same ratio. So what are the corresponding sides? Well, A and root 5 are a pair of corresponding sides. A is the hypotenuse of the small blue triangle, root 5 is the hypotenuse of the big triangle. So if we put A over root 5, we'll get the same answer, or the same ratio, if we put 0.75 over 1. So we have this equation here, and if we solve it to 3 decimal places we get 1.677 meters.